All right, hi everybody. This is HPC Notes for Polynomial Functions Part 3. And today we're going to work on dividing with synthetic division. So there's a long way to do this, which is really old and boring. So we're not even doing that one. We're just going to show you the shorter, quicker way to do that. Okay, so first thing is you have to make sure everything's in order from left to right. That means that it is decreasing in power for each part in parentheses. So in the first part, x to the third, x squared, single x, no x's, and then also in the one that we're dividing by. All right, so we're going to set it up right next to this box, and we are going to write down the coefficient numbers and leave spaces in between. So that's a 1, a 4, a -5, and a 5. Okay, and notice that I'm not missing any exponents. If I were, there'd be a 0 placeholder. All right, next thing is I want to take this part that I'm going to divide by, and it's going to go out to the front. And you're going to set that equal to 0 and solve it, and that's the number that goes in here. So we are going to be dividing by 3. Okay, so we're dividing by the factor called x minus 3, but we are dividing by the actual number by 3. We want to see if 3 is a possible answer to this polynomial. Okay. All right, so here is how we do synthetic division. The very first step you do is you bring the first number down to what I call the answer line. That's your very first step, okay? Your next step is to multiply this number times 3 and put it underneath the next column. So we're going to be doing 1 times 3, and underneath it I'm going to write a big old 3, all right? And then we're going to add straight down. So if I add 4 plus 3 together, I get 7. Okay, and then we're going to repeat this process again. I'm going to do 7 times 3 and put that down for the next one. So the next one is going to be a 21, and that's going to be 16. Do that again, we're going to get 48. Add them up, we're going to get 53. Now whatever is left over at the end, you put into a little box. This is called your remainder. So ours did not divide evenly. It had a remainder. Okay? So what is our final answer? Well, to figure that out, we put the x's back in from lowest to biggest, increasing x's. So this one gets no x, this one gets a single x, this one gets an x squared. Anything that's positive is a plus connector. Anything that's a negative is a minus connector. So this looks like this. So my answer to this is going to be x squared plus 7x plus 16. And then remember when you first learned how to do divide, in the very beginning you could just do a big old R. Okay, so we could say R53, which looks kind of lame. So what we do instead is, instead of writing R53 for remainder, we say plus 53 over what we divided by. Okay, so that matches really closely to what we would have done in real life, regular dividing of numbers. We would normally say it's divided by the thing that we're dividing by in the first place. All right, let's try that again. All right, so first step here, looking at our dividing amounts, our beginning amount and our what's being divided by. And notice this one, I am missing an x squared. So I have to make sure that when I write those down and I write the coefficients down, I also leave in a 0 for the placeholder. So this is going to be a 1, a 0, a -7, and a -6. So notice I'm just taking those coefficients from this part right here. All right, and then what are we dividing by? I'm going to move this over to this side, and if I do x plus 2 equals 0, I'm dividing by a -2. Okay, first step, you bring this one down. Next step, we're going to multiply by 1 times -2, so that's going to be a -2. Next step, do it again. We're going to take this answer down here and multiply it by the number in the box. So that's going to be a 4. Add straight down, we get a -3. Do it again. -3 times -2 is a 6. Add straight down, we get a 0. Put a box around that. That is our remainder. Hey, check that out. We have a remainder of 0, which means it divided equally, which means that there was nothing left over and that we can actually factor this out. So let's put our x's back. No x's for the -3, single x here, x squared for here. So if they wanted to know what the answer is for this one, we would say it equals, if we divide those two things together, we get x squared minus 2x minus 3 with no remainder. We just get to write that's what it does. Okay. For a little bit of foreshadowing, if we wanted to see if that factored, we now know that if we take x squared minus 2x minus 3 and we multiply it, just think backwards, right? We would get x to the third minus 7x minus 6. So we've actually figured out that we can factor that out and get two factored forms, and then maybe I could even factor this one again later if I needed to fully factor something. Okay. All right, next we're going to go on to what is called the remainder theorem. So this is a rule about using those big R's at the end of our divide problems. Okay. So what we're going to do is we're going to set it up just like we're dividing. So I see that they're all in number order from highest power to lowest power. So I'm going to write out those coefficients. So I've got a 1, a -4, a +5, and a +3. And this time, when they ask us to divide, notice it's not in factored form. So because it's just a number, I get to just divide by that number. Okay, so first step is we always just bring down our first number. And I'm going to stop writing that work step in between. I'm just going to write what 1 times 2 is under the next column. And then -4 plus 2 is -2. Okay, then I'm going to take this answer again, the -2, multiply it by the number in the box. That's a -4. Add straight down, that's a 1. Do it one more time and I've got a 2. Add straight down, I get a 5. Put a box around that 5. All right, now, if they were asking us to divide by a polynomial, I'd put all the x's back in. Here is the super cool thing, you guys. I have just found in a super cool way what would happen if you plugged in a 2. So remember, the other way that you could do f of 2 is you could actually do 2 to the third minus 4, 2 squared plus 5 times 2 plus 3. And you're like, Power, that's not that bad. Okay, so we could go and double check our work. So we could plug it in, we'd get 8. This one would be -16. This would be a +10. And this would be a +3. So let's see, what do we get from that? I'm getting a 5 out of that. Hey, it matches. So you're like, okay, but it's easier for me to just plug in. Yes, it is in this case. But there are sometimes cases where it gets really, really obnoxious when you've got those powers and really awkward numbers that synthetic division might actually be a little bit faster and a little bit easier. So let's go and check out one of those. All right, so here we go for this one. So for this one, look at what we would have to do. We would have to do 3 to the 4th power minus 5 times 3 to the 3rd plus 5 times 3 squared plus 5 times 3 minus 6. Now granted, those are whole numbers, so I'm not really horribly suffering here, but it's pretty bad, right? Like 3 to the 4th and then 3, right? Like this is not going to be a very pleasant thing. So instead, this is a 3 to the 3rd. Okay, so instead, let's try the synthetic division and use the remainder theorem. Okay, so we start out with making sure there's no powers that are missing. Write down the coefficients. So that's a 1, a -5, a 5, another 5, and a -6. And we're going to divide by a 3. Okay, so here we go. First step, just bring down the number. Next, multiply by 3, we get a 3. Add straight down. Multiply -2 by 3, we get a -6. Add straight down. Okay, so every time we reach the bottom of a column, we're going to take that number at the bottom and multiply it back by that box number again. So -1 times 3 is -3. Add straight down, you get a 2. And then we get a 6 and a 0. Hey, guess what? If I would have calculated all that out, it equals 0. Now, none of my addition in each column or my multiply got incredibly difficult. Matter of fact, it was pretty straightforward and easy. So in this case, it would have been easier to use the remainder theorem to find out that that answer is 0. Right? All right, so next one. We're going to find all the solutions of the equation. So I'm going to underline that word, of the equation, given that -2 is a 0 of the function. All right, so if I'm going to find all solutions of the equation given that -2 is a 0 of the function, notice that they have taken out the letter y and replaced it with a 0. No biggie, we're still thinking about it exactly the same way. Okay, so they are telling us that if this is a 0, it is a solution. It will work. I will get a remainder of 0 if I use this number correctly. Okay, so let's go and try it. So first step is making sure everything is set equal to 0. Everything is decreasing powers. It is. So 2, -3, -11, 6. All right, and then the number that we're going to put on the outside is going to be a -2 because they just told us that it works. Okay, So first step, bring the number straight down. Start multiplying. So 2 times negative 2 is negative 4. Add straight down, we get a negative 7. Negative 7 times negative 2 is a positive 14. 14 added to negative 11 is a 3. 3 times negative 2 is a negative 6, and that gives us a 0 remainder. So not only is that exactly what we expected up here, but now I have a little face where I can draw a little happy face because I got a remainder of 0 in there as well. All right, so they said find all the solutions of the problem. All right, so here's my problem. I know that one of my answers is, so let's pretend this is my answer line right here. Okay, so I already know x equals negative 2 works because they already told me it did. So I already knew that worked, I just proved it. So if I started out with an x to the third and I divided out 1x, I now have an x squared problem. So an x to the third problem divided by an x is going to give me an x squared problem. So I'm going to put the x's back in my answer, and again, I'm going to start from the 0 side and increase x's. So remember, 0 is a remainder, it doesn't count. 3 is my whole number without an x. This one gets a single x, this one gets an x squared, and again, that makes sense because if I take an x to the third and I divide out an x, I should get an x squared. All right, so now I have this left. I'm going to put a plus in front of the 3. So now if I can factor this, I could find the other two solutions. So let's go see if it's possible, by guessing and checking, if we can figure out, does this factor? So I know it has to be a 2x and an x. The only numbers I can think of to make 3 are 1s and 3s. So it's either 3 and 1. Now if I do the distribution, I'd get a 2x and a 3x out of that. That's yucky. So let's try a 1 and a 3. And if I do those and distribute, that looks like it will give me a 7. So I'm going to make them both negative. Okay. All right, if that's not your favorite method, that's still cool. Remember, we can still do the x chart. Just remember that it's a times c and b on the other side. So in this case, it would be 6 on top, a negative 7 on the bottom. We do a 6 and a 1. They'd both be negative. And then because we have that leading 2, we would divide everything by 2. This would turn into a negative 3, which would turn into our x minus 3. This would go bottoms up, so we'd end up with 2x minus 1 as our other factor. Okay, which is exactly where we got to with guess and check. All right? I'm going to finish this off and set these each equal to 0. And let's go solve them. So this is going to be x equals 1/2, and this is going to be x equals 3. So my answers are negative 2, a 1/2, and a 3. Right? So a polynomial that's a third degree, we should get 3 answers. And so I'm actually getting 3 answers. So an x to the third, 3 answers. I'm really happy. They're all going to be points on my graph. Okay, so this is how I use synthetic division to help me, because otherwise, how would I have looked at number 5 and know how to solve it? I mean, other than using Desmos or a calculator or asking a friend who had these notes from last year, right? Grouping is not going to work very nicely for this one. So this is our fallback plan. It's not incredibly pretty, but it does get the job done if there's a real answer to be found in here. All right? All right, so let's go on to the next part, which is the rational root theorem. Okay? So the rational root theorem basically says, here is how you find your possible rational zeros. So this is like our fallback of nothing else has worked for us. We've tried to do factoring, we've tried to do grouping, we've tried to do GCS, and we're still really struggling. Okay? This works better when the powers are higher, because if it's lower, we could always do quadratic formula if it was an x squared, right? So if it's an x squared item, we go to quadratic formula. If it's an x to the third and it's got 4 terms, then maybe grouping, right? But if it's got 4 terms and they have nothing in common, I'm going to this method right here, this rational root theorem, okay? So anytime it's x to the third or higher and you don't see a pattern in it at all, we are going towards rational root theorem, which is essentially that same, the same synthetic division, except they're not giving us a hint. We have to come up with our hints all on our own of what numbers might work. Okay, so that's why it's possible, because we don't know which numbers work till we actually guess. All right, so first thing we're going to do is we're going to make sure they're in order from highest power down to lowest. This one does not matter so much if there is a missing term, as long as the first term is there and the last term is there. Okay, because if it ended in an x, we could factor out an x from everything and make it a little bit smaller. So here's what we're going to do, people. We are going to look at the constant term first, and we are going to call this letter P. Why is it called P? I have no idea. It just is, okay? On the other side, we are going to take the leading coefficient over here, and we're going to call this Q. Okay, so they say in the formula to get to the possible rational zeros, you are supposed to write all of the plus or minus p's over q's right here. Okay, so here's the way we do that. We start out with p, and we write out all the factors of p. So all the ways we can multiply to get a 4, and we're using integers, right? Don't worry about fractions so much right now. Just give me all the numbers that multiply to make 4. Well, there's 1 and 4, or there's 2 and 2, right? So I'm going to write those all out. I'm going to do them in order. So I'm going to get a 1, a 2, and a 4, right? All of those numbers could multiply to make a 4 if they're matched up. But I was just thinking about positive ones. Negative ones work too. What if I did a negative 1 and a negative 4? That would work. Or 2 negative 2s would work. So they don't need us to put them in pairs. They just want us to list them all. So each one of these is going to get a plus minus in front of it. All right. All right. Now let's go and do the other one. So on the other one, darn it, I did the wrong color. I will adjust. Okay. So for the other one, for factors of Q. Here, this is going to bug me. I got to go fix this. This will drive me crazy. Hang on. So let's make them actually match. So we are going to say factors of Q right here. This is Q. And for colors over here, we're going to say this is P. Okay? All right, so back to factors of Q. That's better. Now it at least color matches. All right, so factors of Q. Q is just a 1, a negative 1. So factors of 1 are positive and negative 1. That's it. Okay, and then the super cool part is the possible rational zeros are all of the p's over q's. So these are all the possibilities that might work if I did synthetic division. These are the numbers I should try. So I'm going to start out with every number from p first and put it over q. So I'm going to have plus minus 1 over plus minus 1. Then I'm going to have plus minus 2 over plus minus 1. Then I'm going to have plus minus 4 over plus minus 1. And I'm going to reduce those, and can we just simplify the plus minuses and say it's just 1 plus minus in front of the whole thing? So this is going to be plus or minus 1, plus or minus 2, plus or minus 4. Okay, so all of our possible rational roots should still have plus or minuses in front of each one. All right? All right, that's it. So let's go try this again. So I'm going to keep the colors the same this time. So this time, P is equal to 3. So P is plus or minus 1 and plus or minus 3. All right, Q is the 15. Q has 1s, 3s, 5s, and 15s. And again, I could match them up with some negative numbers to still make them equal positive 15, so they get all the pluses and minuses. And then lastly, we're going to do all the p's over q's. Okay, so this time I'm going to start out with this 1 and put it over each one of those numbers. So I'm going to have plus or minus 1 over plus or minus 1. I'm going to have plus or minus 1 over plus or minus 3. I'm going to have plus or minus 1 over plus or minus 5. I'm going to have plus or minus 1 over plus or minus 15. Okay, and you're not going to write them with all these plus or minuses. You're going to simplify them. I just want everybody to see where they're coming from. And then I still have to do all the plus 3s. So now I'm going to do plus or minus 3 over plus or minus 1, plus or minus 3 over plus or minus 3, plus or minus 3 over plus or minus 5, and plus or minus 3 over plus or minus 15. So what do those simplify to? Because we don't have to do repeating numbers if there aren't any repeating numbers. All right? So 1 over 1 is really just a 1. Then I see a 1/3. Then I see a 1/5. I see a 1/15. 3 over 1 is 3. 3 over 3 is 1. It's already there, so I don't have to write it again. 3 over 5 is a new fraction. And then 3 over 15 is 1/5, and I already have that there, so I don't need to list it again. So my p's over q's are this many possibilities that if I had to go find an answer, it's going to be in that list if there is a real one, and if it's fractional. Which answers won't it find? It won't find irrational fractions. So it will have a very difficult time finding any imaginaries and any square root numbers that have primes under them. So square root of 2 it will not be able to find. But if your answers are numbers like 1, 1/3, 1/5, 1/4, right? Anything that's a fraction or an integer, it will find it for you using P's and Q's. Okay, so this is the rational root theorem. All right, so here we go. Now we get to actually do this. Okay, so here comes the fun part. All right, so this one, I already know I'm going to have to start with a 1, a 2, a -5, and a -6. All right, I'm going to have to figure out what number I'm going to put here myself. This is my job to figure out what am I going to put here. Okay, so to do that, I'm going to go and figure out P's and Q's. So for now, just for our work step, I'm going to leave out the pluses and minuses. So P is the number at the end, that's the 6. So that's a 1, 2, 3, and 6. And then the Q is the first number, that's just a 1. So if I put those all together, my P's and my Q's are going to be 1, hang on a second. All right, so Q was just 1s, and then we went towards finding P's over Q's. So that would be plus minus 1, plus minus 2, plus minus 3, plus minus 6. That is 8 choices. 1, 2, 3, and 6 are 4 numbers, but a plus is going to be different than a minus. So there is potentially 8 different numbers that might work. Possible rational theorem. Possible. Guys, we got to do this potentially 8 times. All right, so let me tell you a trick. If your teachers are making you do this by hand, they are going to keep the numbers lower because they're going to assume that you start at 1 and move your way up to 6. So do that. Don't just try to jump around and say, I feel lucky, I'm going to try this. Okay, try to stick to a plan and start with lower numbers and then work your way up. You are more likely to find an answer along with us a little bit faster than otherwise. So the first one I'm going to try is I'm going to try a positive 1. Let's go try a positive 1. So I'm going to put in the 1. I'm going to work it through. 1 times 1 is 1. Add straight down is a 3. 3 times 1 is 3. Add straight down is -2. -2 times 1 is -2. Add straight down is -8. Sad face. Why? Because with a remainder, it tells me it didn't divide equally. So this does not work. So 1 does not work. So I get to try it all over again. Isn't this great? Like, this is like living our best life right here, people. All right, so 1, 2, -5, -6, and a 1 didn't work. So I think I'm going to try a -1 next and see if that's any better. All right, so here we go. So bring down the 1 as a first step. Multiply, we get -1. Multiply, we get -1. Multiply, we get 6. Hey, look at that. Smiley face. Remainder of 0, so this one actually works. So when they say find the zeros, what we know is that that number that we divided by actually works. But now I have something left that I still have other solutions to. So remember, this started as an x to the third. We divided out an x. So if I work my way backwards, here is your x, here is your x squared. This is a plus x and a -6. Can we factor it and get the rest of them? So 2 numbers that multiply to make 6, but add or subtract to make a 1. That's a 3 and a 2, and that works only if 3 is positive and 2 is negative. So when I solve each one of these, I'm going to get a -3 and a 2. So I'm going to put those onto my answer line, -3 and a 2. It had a third degree. We found 3 solutions. So we are happy campers. They are all solutions that show up on the actual answer line, on the actual graph. Okay, no imaginaries on this one. They all happen to work and we could find them all. So notice we had 3 that would have worked out of guessing from 8. So we could have found some other ones, but again, general rule, start low, work your way up. And it's easier to multiply by 1 anyway, people, and not screw it up, okay? All right, so there's our first one. 3 solutions, third degree polynomial. That seems to make sense. All right, let's go try these next couple, and we're almost there. All right, so on this one, I'm going to first get it ready to divide. So I'm going to have a 1, an 8, 11, a -20. I notice that there's nothing missing in terms of powers. We have 1 term for every power. Okay, let's go and figure out our P's and our Q's. All right, so this is our P's. Factors for this are 1, 2, 4, 5, 10, and 20. Did I get them all? Let's look at them as pairs. 1 times 20, 2 times 10, 4 times 5. I think those are it. So those are our P's. Okay, Q's are going to go on the other side. So Q's are just 1s. Okay, so our possible P over Q's. Possible P over Q's is going to be 1 over 1, 2 over 1, 4 over 1. It's going to be the same as our original P values. So I've got 1, 2, 4, 5, 10, and 20 to try, and pluses or minuses for all of them. Okay, so at least, if you're not going to write a plus or minus in front of each one of them, at least put parentheses around the whole set and put a plus or minus in front of the whole thing so we know. All right, so I'm going to start out with the number 1 and see if that works. So starting with the number 1, let's see. Multiply by 1, I get a 1. I get a 20. Hey, look at that. Remainder is 0, so it actually worked. Okay? So if I'm listing my answers, what did I just find? I found out that x equals 1. Okay, now it's an x to the third, so potentially there are 2 more solutions that I'm trying to find. So if I put the x's back, maybe I can factor this. Can you think of 2 numbers that multiply to make 20 but add or subtract to make 9? 4 and 5, right? And they're both positive. So set those each equal to 0 separately, and we get x equals -4 and x equals -5. So once again, we have lucked out, and all of our solutions. Third degree polynomial has 3 answers, and they happen to all be real answers, points on our graph that we can actually graph and see. Great? All right, now let's tie it together. We're going to find our answers to these as well, and I'm going to guess ahead of time here that we're maybe not going to find some that are all nice and pretty numbers. Okay? So here is our P's and our Q's. So they said equal to 0, no big deal. Remember, this P's are from here, Q's are from over here. So if I list all of the possibles for P, we are talking about 1s and 3s. And for Q, it's just the number 1. So if I try to put all of those different combos over each other, I am looking at 1 over 1 and 3 over 1. Okay, so that's 4 different choices on an x to the third. It's looking like our guesses are pretty good, right? Like I probably could find one. So let's go set it up and see. So a 1, a 7, an 11, and a -3. And I'm going to start with a positive 1 again because 1s are easy to multiply by. All right, bring down the 1. 1 times 1 is 1. Add straight down, we get an 8. 8 times 1 is 8. Add straight down, we get a 19. Oh, sad day. It is not a 0. It does not work. So I have to try it again. Okay, so let's try a -1 this time. 1, 7, 11, -3. Bring down your 1, start multiplying. This is so sad. This is not going to work either. So the 1s didn't work. So what's my next step? Let's try some 3s. So 1, 7, 11, -3. Now I have to be careful and multiply by 3. 10, 30, 41 times, can we agree this is sad face? There is no way that that is going to make a 3. Okay, so let's try a -3. So again, a 1, a 7, an 11, a -3. This is going to be a -3, a 4, a -12, a -1, and a 3. Yay! So we have found that one of our answers is x equals -3. So I'm going to start a list over here. So x equals -3 is our first one. All right, so what is left? I'm going to put the x's back in, and I'm going to see if I can factor it. Can you come up with 2 numbers that multiply to make 1, but add or subtract to make 4? No way. Can't think of anything. Let me clean that up a little bit. Right? So this does not factor this way. So that means I have to do sad quadratic formula. All right, so here we go. We're going to start out with -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so I'm going to see if I can simplify the square root value. So this is going to be 16, ooh, where did that go? 16 plus 4, right? A minus and then a -1 is going to turn into 16 plus 4. So I'm going to call that 20 all over 2. All right, so what do I do with this? Well, these are actual answers. It's just that one is in radical form. That's why I'm not finding it from P's and Q's. So important fact here is when we are using synthetic to try to find answers to polynomials, sometimes we have to use what's left over once we hit the quadratic level, once we hit x squareds, to find our answers other ways, because synthetic division only helps us to find real answers as fractions or whole numbers, positive or negative, so integers, okay? And then fractions, so that's why it's called rational. It only can find the fractional, rational, positive, and negative numbers, all right? So if you can get down to an x squared, you can always go to quadratic, and quadratic solve anything that you can't factor or synthetically divide. All right, so now I just have to simplify this. So there's a bunch of different ways to simplify this. There's going to be two answers, a plus and a minus. I'm going to go ahead and work out that 20 and say that is square root of 4 times 5. So I'm going to say that that is plus or minus 2 square root of 20, right? Because if I take the square root of 4, I'm going to get a 2 on the outside. Oops, and then not a 20 on the inside. I'm going to get a 5 left over. All right, now I can't just reduce the 4 and the 2, right? But I can factor a 2 out. So if I factor a 2 out, I'm going to get negative 2 plus or minus square root of 5 all over 2. I can't separate this plus and minus team, but I can factor out the 2's that have already been factored out. All right, so my next answer is going to be negative 2 plus square root of 5 all over, nope, not even all over. And then my other one's going to be negative 2 minus square root of 5. So there are my three answers. They are still real. They're still graphable. I just need a calculator. I need to estimate what square root of 5 is. Okay, so this one still works. It's just when I get down to that x squared side, I've got to go to quadratic formula. Okay? All right, let's try one more. We getting the hang of this? Feeling pretty good? Have you done this before? Is this a review? All right, what I notice on this one is I am missing an x to the third, so I have to remember to keep a placeholder for that. So 1, 0, negative 6, negative 8, 24. Let's go and do some p's and q's. So p is all the factors for 24. So that is going to be 1's, 2's, 3's, 4's. 4 times 6, 3 times 8, 2 times 12, and 1 times 24. And then all of the q's, thank goodness, are just 1's. So this is going to be plus or minus the original p values all over 1. Okay, so that is 4, 5, 6, 7, 8 numbers to guess with for an x to the 4th. 8 numbers, you guys, to guess with. Whew, what should we do? What should we try? Well, what I would actually do on this one, to tell you the truth, is I would cheat. I would go and look and take a look and see what we have going on Desmos maybe. And I would go and take a look at that graph and see if I could figure out what that graph might look like. So let me see if we can do that really quickly for us. And I'll bring it into the screen. Okay, so graphing calculator. All right, again, I could try ones and do all that stuff. I'm feeling a little tired of the whole thing. So let's see. So I'm going to write in y equals x caret 4, and then minus 6x caret 2, and then minus 8x, and then plus, where did my plus button go? There it is, plus 24. Okay, hopefully this is in the screen. This is the first time I've done this with Desmos. What do we notice? Remember, the cool thing about Desmos is that it gives you all the important numbers. Hey, x equals 2 works. I think we should try it too. Okay, so I'm going to try it too. I'm going to move this out of the way. So all I did is I typed it into Desmos and I said, hey, let's try 2. I think a 2 might work. Okay, so bringing down my first number, multiply, 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 and one last time, hey, look at that, we got a 0. All right, so what does that tell us? It tells us that x equals 2 is one of my possible answers, right? It is an answer. It's not even possible. It is an answer. But remember, it's got an x to the 4th, so there are still 3 other answers out there. And if I started with an x to the 4th, and I divided out an x, I still have an x to the 3rd problem left. So this is 1x to the 3rd, with an x squared with a single x. And again, if I start and go this way, that makes sense. No x for the 12, a single x for the 2, then an x squared, then an x to the third. So I am left with x to the third plus 2x squared minus 2x minus 12 is my remaining amount that I'm still trying to factor. All right, so here's the cool thing. So I could keep going with synthetic division and just pick another number and see if they still work. Not only that, but when I do that, there is a good chance that some of my p's and q's have been eliminated. So now notice that when I'm doing p's and q's, p's are coming from the number 12. So now I only have 1, 2, 3, 4, 6, and 12. Okay, the numbers 8 and 24 have been removed. They're not going to help me make a 12 anymore. Okay, so now I have what's left here to try to do what's left and see what we could do here. So what should we try to divide this one by? Well, do you remember when we looked at Desmos? It only had that one. Oh, it had a bounce, right? So if it had a bounce, we're going to get another 2. Another 2 should work. So let's try this again for another 2. So add straight down, multiply by 8, add straight down, multiply by 2. I get a, oh no, did I do something wrong? I certainly hope not. Oh, right there. Plus 6, plus 12, happy face, 2 really does work. And I'm left with x squared plus 4x plus 6. So guess what? I now have another 2 that worked. So this was an x to the 4th. There are 4 possible solutions for an x to the 4th, right? We have found the 2 real ones. And remember, looking at the Desmos graph, it only had those that touched the x-axis. That was it. So we still have to figure out what are we going to do with what's left. Does this factor? Do 2 numbers multiply to make 6 and add to make 4? 1s and 6s won't work. 2s and 3s won't work. So I'm out of ways to do that, but I do have an x squared, which means, dun dun dun, I can use quadratic formula. So here we go with quadratic formula again. X equals negative 4 plus or minus the square root of b squared, which is 16, minus 4 times 1 times 6, all over 2a. Okay, let's look at that square root system over here. This time, I'm going to get 16 minus 20. And 16 minus 20 is negative 4. Okay, and here is our first chance when we have a negative. The very first thing that you do when you have a negative is you move an I out in front, and that becomes the negative 1. So, new rule, right? Square root of negative 1 equals I. So the second that you see that, you immediately turn it into an I on the outside. You do not wait. You don't deal with the 4 first. You move that I out very first step, right? All right, we're still all over 2. Okay, now square root of 4 I know happens to be 2. So I'm still going to have x equals negative 4 plus or minus. The 2 is going to come out, and I'm going to get a 2i all over 2. We're going to go ahead and factor a 2 out of the whole thing again. So I'm going to get negative 2 plus or minus I all over 2. Those factored out 2's go away. And there are my 2 remaining answers, negative 2 plus I and negative 2 minus I. Yes, so negative 2 plus I and negative 2 minus I. Okay, so there are 4. Now 2 of them were real. We saw them on Desmos. The other 2 were imaginary numbers. So we still get 4. It's just 2 of them are real and 2 of them are imaginary. So these 2 are the real ones. They're what caused the bounce. And these 2 are my imaginary ones. So that I still get a total of 4 solutions. Okay? So there are 4 solutions because it's next to the 4th every single time, right? It's going to match that degree. But if they ask how many x-intercepts there are for this one, even though it's next to the 4th, it only has 2 x-intercepts or 1 with a multiplicity of 2. All right, so we got to be careful with our vocab here, right? So what are all the words that we've talked about for solutions before? Let's go back over those really quickly. So we have a solution, we have a root, we have a 0, and we have an x-intercept. Okay? All right, this is the only one that means real. All of the other ones could mean real or imaginary. So if they say solution 0 root, we don't care. It all means the same thing to us. We're just going to go find those answers. But if they say x-intercept, make sure you're only giving them the real answers. So in our example, we would only have given them the only real answers were 2 with a multiplicity of 2. Okay? So if they ask for x-intercepts, don't give them all the i's and everything else. You can give them square root numbers. Those are real. But don't give them any I answers. Okay? So no imaginary answers. All right, and that's it for today, guys. All right, we'll see you later.